Hello and welcome back to the API Portal Masterclass series. I am Alex and today I will demonstrate the high availability API Portal reference environment. So as like any other web application, the API Portal consists of two main layers, which is the web server layer and the database layer. When you are building a high availability architecture or environment for your web application, you need to make all of the components of your system highly available. So in our case, this means that we need to make highly available our web servers, and we need to make highly available our database server. In order to achieve that highly availability, you usually need to have more than one web server and more than one database server. So the solutions that provide that kind of architecture are called clusters. So we're gonna be talking about the clusterization of API portal of web servers and clusterization of database servers. Now, for the needs of the API portal, we don't need to actually clusterize the web servers. We just need multiple web server instances and a clusterized file system. Okay, so as you can see here on this picture, which is available on the new page in our documentation that we make with this release, which is describing in details our example HA environment. So it describes in detail how to build the same environment, and it describes the tools that we used to build it. So looking at this picture, we can see that we will receive traffic from internet. It will go through a load balancer, which will redirect the traffic to either API portal node 1 or API portal node 2. They will share a file system between them, which is a cluster itself. For this part, we use a tool called GlusterFS. It's very commonly used and known tool. It provides a clustered synchronized file system, which means that you are using multiple nodes for having the same file system on it. And if one of the nodes goes down, the other nodes continue to serve the file system so that API portal can read from it. Okay. The second part of it is the database clusterization. We will talk about it after that. First, let's start with the first part of the picture. Okay, in order to demonstrate that, I created some local domains. One for the load balancer that we will be accessing all the time, and two separate local domains for each of the internal API portal nodes. Now, in a real use case, in a real scenario, you would not allow direct access to those internal nodes of the API portal. You will allow only the access to your entry point, to your load balancer point. But for the purposes of this demo, I have allowed the direct access to those instances just to show the synchronization between them. Okay, so first let's access the HP load balancer here. It is I call the local domain API portal.external. Okay, and there are two more domains called API portal node 1 .int and API portal node 2 .int. Portal node 2. Okay. Now, in order to be able to to see how the traffic is load balanced to both of the servers, we will be using a SSH client. So let me split the screen here and show the SSH client. In this SSH client, we will connect to both instances, API Portal Node 1 and Node 2, and we will look at the access, the HTTPD access walk. Okay, let's first connect. Okay, connect to the second one. Okay, now let's tell the Apache access walk. Sorry. Okay, and do the same here. Okay, so on the left side of the SSH client here, we are looking at API Portal Node 1, and on the right side, we are looking on the API Portal Node 2. And on the left side of the screen, we are looking at the API Portal load balancer point. Okay, so now let's access, let's say, the sign-in page of the API Portal. As you can see, both instances receive traffic. So that's pretty normal. Somewhere here is the actual sign-in request. Here, there it is. So the actual sign-in request got to Node 2, but this is not the only one request needed for the browser to render this page. It also needs to request other resources like CSS, images, JavaScript, and so on. So it's actually multiple requests to render this web page. So as you can see, those requests are spread across different nodes. Now, I will stop this node, the node 2, in order to demonstrate how the API Portal application will continue to operate normally, no matter that one of the nodes, one of the web servers is actually down. Okay. Now, in the real world, it's gonna be some kind of a accident that the web server would stop. But in order to simulate it, we will just stop the service here. Okay. Now let's tail the walk again to see that it does not receive any traffic anymore. Okay. Second. Okay. Let's refresh here. Now, as you can see, all the traffic is received by only the node 1. Node 2 does not receive any more traffic, but the API portal is still operational, of course. Now, of course, you could have as many API portal instances here as you wish. For the purposes of this demo, there are just 2, but you can have 3, 4, 5, etc., as many as you wish. Okay. And until at least one of them is operating, your whole application will be operating. Now, there are some complex scenarios and details for the clusterization part of the file system, like with any cluster. Yeah. So, administrating a cluster is not very easy job, and it requires a certain knowledge. So we won't go into many details for clusters here in this demo, but you should know that you should follow some best practices, like always having at least 3 nodes for your clusters, or any odd number of nodes, in order to not have the so-called split brain problem and so on. Those are common issues with all the clusters, and they are very well known good practices to follow in order to solve those issues, or actually to not have those problems, I should say. Okay, now let's again start the node 2 instance. Okay. Now, since we demonstrated how the traffic is redirected to both of the nodes, and if one of them is down, the other one is still operating and your application is still up and running. Now let's demonstrate the synchronization part, which is actually the GlusterFS magic here. Now I will create a file on the file system of one of the nodes, let's say on node 1. Actually, I don't know on which node I will create it, because I will do it through the load balancer. So it will get to either of those nodes, but because of the synchronization part here, it will be instantly replicated to both of them. Okay, so I will go to the Jumo admin interface here, and will, okay, let me first log in. Okay, we can just ignore those messages. It's just the PHP version of my local environment here that Jumo doesn't like. It's not something important now. Let's go to the media folder. Now here, I will create a folder from here, and it will say demo HA. Okay, demo HA. Now, if I go, as I explained, I've allowed direct access to those instances just to be able to showcase this specifically. I will now go to the Jumo interface on any of those two instances, and access the media folder. And I see that I already have this demo HA folder. Let's access the second node. Do the same, go to content, media, and again we see that we have this new just create demo HA folder. Okay, now this folder is empty. There's nothing in it. So let's put something in it. Okay, empty again on node 1 and node 2. Let's go to our load balancer, pretend that we have never been accessing the node 1 and node 2 directly. Let's pretend we just access all of it through the load balancer only. Now I'll go here. Right now we don't need a SSH client, so I'll just extend the browser here. Let's go to this folder and upload a file in it. Let's say we upload something from my gallery or something from my pictures folder. Let's upload this nice Asteriolas pieces. Okay. Hit upload. Okay, we already uploaded. Now let's go and check what happens here. We see that the image file that we just uploaded is immediately replicated on both of the nodes. This is happening because of this shared file system. Okay, and in order to further prove that, I will again show the SSH client, and we'll show you that this is actually a physical file on the file system. So let's go to the API portal install folder. Okay, the media component is actually writing files in this images folder. As you can see, we have our demo-ha folder, and in it we have our Yoda species PNG file. Okay, let's do the same on the Node 2 instance. Again, we have this folder demo-ha, and inside it we have the same PNG file. All of it is synchronized because of the GlusterFS, the shared file system. Okay, which means that no matter which server is down, the other one will read the same file system because they are reading from the same place. Okay, and the file system itself is clusterized, so no matter how many nodes of it dies, and until there's at least one working, the whole application will be available. Now again, there are some details into synchronizing the data in a cluster when a node is down and when it rejoins the cluster. There are different strategies about that. You should just go into further details and read more for your chosen cluster solution in order to make the best of your cluster capabilities. Okay, of your solutions cluster capabilities. Okay. Now that's for the web server part of our system, of our API portal system. Now let's go to the next layer, which is the database layer. Now, for the clusterizing of the database layer, we used a tool called Galera cluster. So it's a commonly used, again, and very well known tool for clusterizing MariaDB servers. Again, the access to those database servers happens through a load balancer, another load balancer that both of our web servers are connected to. So it redirects the traffic to either of those three nodes. Now, for the purposes of this video, I have only two nodes, but again, it's a good practice to have at least three. So please consider for your production environments, have at least three nodes. Just for simplicity, I'm using just two right now. Okay. Now, in order to demonstrate the synchronization between those nodes, I will do something that will change the state of the database. So again, we'll go to Joomla, and this time, instead of uploading a file, I will create an article. First, I will use a database client, which is with a graphical UI client. Just I've already connected to my two database nodes here. So it says DB node 1 and DB node 2 with as you can see, different IPs here. So I will show you the articles table, which is actually the content table on both of those nodes. Okay, and we will see how the new article, when I create it, it will appear here on both of them. Okay, let's open it on Node 2. Okay, now let's go back to the server and let's say we create a new article here. It will be called demo HA and some test article text. Okay, save. Now I did this through the load balancer, and I expect that. So I access the web application, my Joom admin interface, through the load balancer. I'm not interested in which node it hit. That's not important right now. Then when I click save, it executes an insert query through this load balancer. It gets one of those nodes, no matter which, and writes the query there. But because of the Galera cluster, it will get synchronized between all the nodes. In my case, between just node 1 and node 2. Now I expect that I have those records with the newly created article on both of the database servers. Let's see if this is true. Let's go first to DB node 1. We refresh the content table, and we see that we have demo HA with some test article text here. Okay. Now let's check that on DB node 2. We refresh here, and we see that the same record is also replicated on DB node 2. Okay, that's for the synchronization part. Of course, we can again directly access the node 1 and node 2 Joom interface and see that the newly created article will be here on both of them. Okay, and now in order to prove the high availability, I will just go and stop one of those servers. Now, just give me a second. I will use one of those IPs, let's say this one. And again, with the SSH client, I will connect to it. Okay. So it's 10.133.66.139. Okay. Okay, now let's just say system control stop MariaDB. Okay, let's first say status MariaDB. It's active, so let's stop it. Okay, status inactive. Now let's check our API portal application again. We refresh, and as you can see, it's still operating. The article is still here. I can access it, and our application is actually available. So again, that's all for the demo part of this video. I hope you enjoyed it. We will be glad to answer any questions that you have. Again, this is just an example environment, just an example configuration. You need to adapt it to your own use cases, your own resources, and your own requirements. It is just something that proves that the API portal can work in a highly available environment, and it's an environment that we test against. Okay, it's not the only way to achieve that. There are different cluster solutions. There are different file system sharing solutions. There are different database cluster solutions. There are different load balancer techniques, technologies. So it's just one example of how you can set up this. please do read carefully this page if you want to have such kind of environment, adapt it for your needs, or reach out to us. We'll be glad to help with what we can. So thank you very much for watching, and bye bye for